Hi, welcome back to Moose and Chemistry. This is Redox Oxidation Reduction lesson number 3. Okay, so let's look at our original charges here for our copper. It's going to be 0. Nitrate's a -1, the hydrogen be a +1. Right. This nitrate here is a -1, this copper would be a +2. Ooh, that's interesting. This oxygen over here is -2. This nitrogen would be a +4. This is -2. This is going to be +1. Okay, well, first of all, let's look at here. Okay, so our copper is going to change from a 0 to a +2. Alright, so when that does that, that means it's going to lose electrons. Matter of fact, it's going to lose 2 electrons to be exact. So Leo the lion goes grr, right? Leo lose electrons oxidine. Grr, gain electrons reduce. Well, guess what? I'm just going to call this O for oxidation. Okay, let's look at something else here. Alright. The last one we need to look at is, okay, our hydrogens don't change. Okay, and let's see what else here. This nitrogen right here is a +5, and it's a +4 over here. So this one is going to grr. It's going to gain an electron. It's going from +5 to +4. It's gain 1 electron, so we're going to call that reduction. Okay, that one's kind of hard to see, but there you have it. All right, now, the next problem is a little bit different. We're going to use redox to help balance this equation a little bit better, I think. We're going to try to. So we're going to originally give this a 3+ charge. And we're just going to try it this way. And this is going to be a 2- charge. And so this iron is going to be right here, 2+ charge. We're just going to arbitrarily assign these, and then remember they're supposed to be zeros unless we tell you otherwise, so we're telling you otherwise, okay? So we get a 0 here. Alright, so now let's look at this. We're going from a +3 to a +2. So we are grrring here. We're grrring at a fact of 1 electron, okay? We're going from a -1 here to a 0 here. So we're Leoing here. 1 electron. There. Okay? But let's see what we got going on here. So we're each going by 1 electron. Okay? Now, what we're going to do is, we had 2 of those eyes, right? Since we had 2 of those eyes, we don't do 1 electron. We have to multiply that by 2. So that actually gives me 2 electrons that we lost, because we lose an electron per eye. Alright? So look at this. We've got 2 electrons here and 1 electron there. So what we're going to do is we're going to multiply this side by 2 and this by 1. And when we do that, we're going to do this. Okay, now watch. This is going to become 2 times Fe. This is going to get really kind of confusing, but it's going to be fun. 3 plus 1 electron, that's how many up, yields Fe 2 plus, and this is going to, other one's going to be 1 times 2I, that's our negative, which yielded I2 0 plus 2 electrons. So when we do this, this gives me 2 Fe, right? 3 plus 2 electrons. Because remember, this 2 was multiplied in this whole thing here. Okay? So that would give me, of course, 2 Fe, 2 plus. Because what you do to one side, you're going to do to that other side, it looks like. So we're also going to multiply that side by 2. Okay. Now, this bottom one is going to be 2i negative yield, because anything times 1 is that same number. I2 0 plus 2 negative. Now look at these electrons, these 2 negative electrons. They're on opposite sides of the yield sign. So let me show you something. So you can get rid of this one and this one like that. And when you do, now we can write our equation. The net ion equation, whatever you want to call it, is going to be 2 Fe plus 3 plus 2I negative. As you see, they're on the same side of the equation over here. Yields 2 Fe plus 2 plus I2O. And you can see that everything is balanced. Pretty darn snarly, huh? Well, we'll see you back here at Musa Chemistry, guys. This was really interesting. And wait for more to come. Take care.